In order to find the area and perimeter of this triangle, we need to first sketch a picture of it so we know what we're working with, and then we'll have to figure out what the side lengths are. All right, so the first thing I'm going to do is plot my points. So I have -4, 3, that would be up here, and that is my first point. -2, -2 is here, and then 8, 2 would be over here. So I'm going to connect my vertices so that I can see my triangle. Now I can't say for sure right now, but it looks like this corner right here might be a right angle. So that's something we'll check when we get closer to that part of our problem. So the first thing I need to do is figure out all of my side lengths. So let's use the distance formula. So I'm going to write the distance formula up here. So that would be x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of both of those things. Okay, so I'm going to do 2 pairs of points at a time. So let's first use the points -4, 3 and -2, -2. So I'm talking about this point that's right here and then this point that's right here. So what we're going to find right now is this side that I just went over in blue. So I'm going to label this x1, y1, x2, y2. And now I'm going to plug my numbers into the distance formula. So I'm going to say d equals, and I'm going to set up my formula without putting numbers in so that when I do put the numbers in, I don't really have to think too hard. All right, so x2 minus x1 would be -2 minus -4. And then the next parentheses is y2 minus y1, so that would be -2 minus 3. All right, so the next thing we're going to do is we're going to put everything into our calculator, and by everything, I mean everything under the radical, and it gives you 29. So that tells me that this side of the triangle has a length the square root of 29. Now let's do another side. So let's pick the points -2, -2, and 8, 2. So now we're looking at this side of the triangle that I'm going over in orange. All right, so I'm going to label x1, y1, x2, y2, and we'll do the same process. So I'm going to put in my blank formula, and now let's put in our numbers. X2 is 8, x1 is -2, y2 is 2, y1 is -2. So I've got all of my stuff written in there. Now we have to plug it into our calculator, and I'm talking again just about the part that's under the radical. I'm not actually putting in the radical. And it gives me 116. So 116 is kind of a bigger number. It's not a perfect square, but we do have to just kind of double check to see if it is something that we could simplify. So I'm going to do this off to the side. Because 116 is an even number, I know for sure that I can always divide by 2, and when I do, I get 58. 58 is again an even number, so I'm going to divide by 2 again, and I get 29. 29 is also a prime number, so I'm done now, but I did come out with a pair of 2's here. So that means that I can take a 2 on the outside, and then the square root of 29 will be left over. So this turns into 2 square root 29. Okay, and then we have to do our final side. And that one is if I take the 2 points -4, 3 and 8, 2. So we're talking about this point here and this point here, so this line that I'm going over in pink. So I'm going to label my points, x1, y1, x2, y2. I'm going to set up my blank formula. And now let's plug in our numbers. X2 is 8, x1 is -4, y2 is 2, y1 is 3. So now I'm typing this into my calculator, just the part that's under the radical, and it gives me 145. All right, so again, I have to see if I can break it down and simplify it at all. So whenever you have anything that ends in a 5, I think the easy choice is to see that it divides by 5. So if I divide 145 by 5, I get 5 and 29. Both of those are prime numbers, so that means that I actually cannot break down the square root of 145 because I don't have any pairs of numbers. So this is the square root of 145. Now, that tells us the lengths of each side. But in order to figure out, so I can figure out my perimeter right now. And actually, let's just do that. So to find out my perimeter, I need to add all of the sides. So I would do the square root of 29 plus 2 square root 29 plus the square root of 145. Anything that has the same radical, I can add together. So that means these two terms right here, I can add them together. Even though it's not there, there's like an invisible 1 here in front of the square root of 29. So I have a 1 on the outside plus a 2 on the outside. So that gives me a total of 3 square root 29. And then the one that's in pink just tags along. So you don't have to add it to anything. It just kind of stays as part of your answer. So that's my perimeter. For the area, things are a little bit more complicated. We have to make sure that this is a right triangle like we suspect. And I happen to think that the easiest way to do that is to check that the Pythagorean theorem comes out equal on both sides. So what we're going to do is we're going to check that c squared equals a squared plus b squared. So c, remember, has to be your longest side. So we're suspecting that the square root of 145 is our hypotenuse. So we're going to do the square root of 145 squared, and we want to see if that is equal to the other two sides. And it doesn't really matter which one is a and b, so I'm just going to kind of randomly assign those. So I'm going to say that the square root of 29 is a, and then 2 square root 29 is b. All right, so whenever you square a square root, they cancel each other out. So the square root of 145 squared is just 145. The square root of 29 squared is just 29. And then 2 square root 29 squared would actually turn into the square root of 29 times 4. Because this 2 would square the 2 and the square root of 29. So 4 times the square root of 4 times 29 is 116. And if I add 29 and 116, it does give me 145. So I know for sure now that this is a right angle. All right, so that's good news. Now we can actually figure out our area, and I've kind of run out of room here. So to find the area, I'm going to just try to squeeze it right here. Remember, the formula is 1/2 base times height. Now that we know this is a right triangle, I can say that either of the two legs is the base or the height. It really doesn't matter. So I'm going to say that the square root of 29 is the base and 2 square root 29 is the height. So for the area, we would do 1/2 times the base, which we're saying is the square root of 29, times the height, which is 2 square root 29. So two things are going to happen here. This 1/2 and the 2 are going to cancel each other out, because they're both outside of a radical. And now I have the square root of 29 times itself, and whenever you have a square root times itself, it just turns into that number. So that means that the area is just 29.